So we got this awesome preview from Megan demoing a full stack application where over the last week we've learned how to use the Django web framework, this Python backend framework, to write this. Really, Django is like the Swiss Army knife, or some people have compared it to sort of a hub where it is both code to interact with our Postgres database, so we can work a level up from SQL using Django ORM and Django models, so that we can use the power of object-oriented programming and migration files to interact with our database and like create and recreate databases in a controlled manner. And we've seen how to use serializers to take that model data and turn it into JSON. And we saw at the end of last week then how to start writing routes in Django, right, in URLs PY, that we can use both to, when we get an HTTP request, grab some information from the URL, and so we can use Django's REST framework's API views that connect these serializers and models and everything together to send the data that we care about back. And Megan just gave us a preview of where that data is going, which is, hey, now we're going to use those React apps that we built, but we're going to build a React app to interact with our own API. And so that's going to be the main focus for today. And we're going to build out our Pokédex app yet even more. And there are a lot of moving parts here now. So I do kind of want to step through conceptually a little bit what's going on, though I realize this diagram has a lot of pieces to it. So there's a couple key things here that I'm just going to kind of circle in red to keep in mind. The first thing is that, you know, for everything we're learning in class, it's all happening on one computer, right? Your computer, which like I'll refer to as like, you know, dev machine or like our local machine. And that IP address that we keep seeing, 127.0.0.1, that is the IP address that always refers to, I believe, like whatever the host machine is, essentially, which is our computer. You'll sometimes see localhost, which is basically like the domain name alias for that. So, you know, the thing to remember is that what we'll learn later to do is later on, Django server will go, say, on server on AWS in the cloud. Oh, and it doesn't want to let me move the text around. So that, you know, for development purposes, we are running the Vite dev server and which then lets us open up the React app in our browser. We're running Postgres, we're running Django server, all on the same machine. However, when we deploy these so that the rest of the world can use our apps, when we deploy them into production, often these are on different machines, and the Django web server might be on one virtual server in the cloud and Postgres might be on another, and we would have maybe a different server to serve up our React application on another server in the cloud, and then the user's browser is, you know, wherever the user is. And that's kind of why there are all these pieces, and that everything is talking to each other with these HTTP requests. So for our local development now, we have these three pieces of Django server and Postgres, right, which are these two programs that are running. And then going back to the React week, we have Vite runs its own little web server that serves up that index.html with that one JavaScript file that has all our React code bundled up, that then gets run in our browser. And it's really then the browser that's talking to the Django server and these requests go back and forth. This is definitely a good document to review later. I think this is a really well laid out diagram. But I just wanted to comment on this a little bit and just to kind of walk through this as well using Excalidraw. And let me go ahead and clear all my drawings. Let's just say the browser and the server, and I'll maybe throw in the database as we go. And let's use the pets example that we just saw. And remember that our React app actually gets loaded into the browser and is running inside of it. And then we've got our Django web server. And just for completeness sake, I'll put Postgres over here. So let's say in my browser, I've already gone to the whatever port the dev server is running. My React app is already up and running. So React is already running in my browser. So then I click on a link like we saw in Megan's app. Maybe I click on, say, the owner's page. And let's just say it was, I think something like this. And let's say too that these are all Axios requests, right? That this is not the React router front-end routing, which is actually kind of its own separate beast, though we can sort of, grab data from it to use in our app when we make Axios requests. So I click on owners and my React app sends an HTTP GET request to whatever URL I want, which in this case is API/v1/owners. Django gets that request now, and it has to, have in URLs py somewhere. It has to have, as we saw, something like this, API/v1/owners. And then, it was API view owners. I think this was maybe the way to call it from something along those lines with the Django REST framework. And so the request comes in, Django hooks in here, and then we have all these different interrelated pieces happening. We have one, the Django path in URLs.py. We have two, the Django view function, and that uses I'll just an API view. Which is this cool class that we get from Django REST framework, which itself uses I'll just stop saying Django, right? We had, remember, let's say the owner model, and then we also had, I think it was the owner serializer. So there's all these things that start getting linked together. And then, of course, as a part of this, Django does also talk to Postgres when it wants to get data. And let's actually. Right, and I think we saw from Megan's code in the view function, like def, yeah, owner. It looked something like owner objects find, or really we could just do owner objects all if we're just getting all the owners. And we run this query and then we pass it into the serializer. So all these things start to be connected. And so every time we get a request to one of our Django API endpoints, it goes through all these steps and we have to have that URLs PY to match. And then Django sends back a response. And this will have some data in it that looks along the lines of something like this. As might be an array, right? And it might have, I don't know, just ID 1, name, Alice, ID 2, name, Bob. And so with every HTTP request, we get a request and a response. And what's cool about this API that we wanted to build with Django is our HTTP responses usually include in the body of that response JSON data. And that's why I was sort of, Megan, encouraging you to open up the network tab. That can be a useful debugging tool, and also just to see this flow and get used to it, though we get some useful help from Django as well. So I do want to start talking about like getting into like building our code and structuring our project. But I do want to check in and see if folks have kind of any questions about this flow. And please just fire away. And if needed, I might just say, well, that's a great question, but we'll come back to it later. But I did kind of want to talk through this a little bit and get you all to start thinking about, we're building this distributed system with these three pieces now, right? The web server, the database, and then the React app running in the browser. And they talk to each other with these HTTP requests. So I'm curious what's on people's minds.
I had just a kind I don't know, it's kind of off top. No, I don't know, not really. But um for our personal projects, are we going to be able to, is there going to be a way for us to use SQL if we wanted to, or are we kind of expected to use ORMs only? Because yeah, I just prefer SQL so much more, but if I have to, I obviously will.
Yeah, that's a great question. So there's definitely a way to like sort of execute raw SQL queries, so to speak, with Django and Django ORM and PsychoPG2. The reality is, and there's a lot to be said for it, because I agree that Django models add a degree of complexity. However, kind of the deal with these batteries included frameworks like Django is you don't want to fight the tool. It actually ends up being more trouble than it's worth, because you might be able to like start building a bit of an SQL query, but then you might run into all these weird edge cases, and it's just not really how Django is designed to be used. I'm sure there's exceptions to that rule, but I would say in the future, for other projects, and maybe down the line, like as you start to become more comfortable with Django and you kind of want to break that rule and just use SQL. But yeah, Django models is what we're using here, and I would recommend that, both because I think, I'm not sure off the top of my head, but my guess would be kind of fighting the way Django wants to be used is actually going to end up causing more problems. And also because although there is a bit of extra complexity, there's a lot of power here, and that's kind of why we're pushing you all to see this as well. Because I think part of the challenge with models is it's a bit more complex object-oriented programming, right? Because we're using classes that other people wrote, and we've got this models class and this serializer class and this API view class, and it is more complex. But that's part of what we want you all to learn and start getting more comfortable with. And similarly, it's a bit more complex to keep track of, all right, I've got a model, but then I need to run like this full clean validation and save the data to Postgres. And there are these Postgres tables, but that's actually separate. But again, that's actually a really important concept as well. Like, it's not just Django where you see these ORMs, like with Django models, you see them in other backend web frameworks as well. So even if you don't use them where in your first job or sort of where you are in your career, it's important to know about them.
Okay, cool. Yeah, I'll stop being a baby. Thank you.
No, it's all good. Honestly, that was a really good question. And I have to say, I do feel like the first time I worked with Ruby on Rails, which is very similar to Django, one of the biggest learning curves for me was definitely like dealing with like models and the Django console and stuff. So it's definitely a bigger lift. But I think also the personal project will start giving time for that. Yeah, honestly, no, that's a great question, Josh. And certainly for smaller projects, if I'm not using something like Django, I like writing SQL as well. Really, the extra effort of models pays off because then we can hook it up to serializers and views. And once you get comfortable with that, you can start building a lot of backend API endpoint type stuff very quickly. What other questions do people have? Okay, cool. Do we want to take a 5-minute break? Yeah, can I get a couple of voices of yays or nays?
Sure.
All right,
Yeah.
I'm calling it. I suggested it anyway. Let's take 5, and then I will we'll start seeing how to build the project structure to have a full stack app in one GitHub repo. So let's take 5, and I'll see everyone shortly. Awesome. So we're gonna see how to build the front end and where it fits in with an overall project. And then really the second part of the lecture will be about making Axios requests and stuff. So we will have some work time, though, depending on, I think, like how far the assignment goes. The work time might be a little project setup, or it might be towards like the end of class. I've done a little setup here in the demos and notes repo. And let me go ahead and open this in the sidebar. So this is the basic project structure that you're gonna be building for now for full stack applications. Sometime the front end refers to pretty much everything that happens in the user's browser, aka the client, aka a React app. The back end is everything happening server side, aka our Django application. And Postgres, we don't handle a bit separately, and Django really does most of the work there. But that as well if needed. So you want to keep these separate. Down the line, you may have separate repos entirely. But for learning purposes and portfolio projects, and often in the real world, Sometimes you might want it all in one repo as well. So this is a pretty good structure to see. You'll want a README, right? In your README, you'll want to describe your project structure. It's not uncommon to even have READMEs inside of each of these. And for the backend, just to go in here really quickly, I pulled the Django code from last week that we were looking at. And I put my virtual environment directory in the backend directory here. You could put it at the top level of the project as well. Sort of makes sense, I think, to put it there, but not a huge deal. And you can see that this is my Django project here. This SQLite file, by the way, we can delete, but I've got manage PY, I've got the Django apps, I've got the Django project, I've got requirements.txt. So I already did this a bit earlier, but if I had just maybe cloned this repo, you know, I would have to run again, or excuse me, I would want to first create my virtual environment. If I hadn't, I'd want to activate it. I'd want to install my requirements, and I already did, which is why I'm seeing all of these requirements already satisfied messages. And remember that the Python virtual environment doesn't affect anything other than Python. So it has zero impact, whether it's activated or deactivated on a React app and everything that we're doing in the front end directory. And then to make sure everything works, I would want to just run my server. And if I check this out, right, this is my Django server running on port 8000. I'm getting this error right now because there is no path for my project homepage. I can see all the things that we kind of wrote the other day. And just to sort of recap, maybe with Pokemon, by hooking up the Django REST framework, we get this really nice API view, right? And in fact, I can use, there's a great tool called Thunder Client as well, that I can use to do HTTP requests inside my browser. And I highly recommend using this. I think the workflow is a bit better when developing, though you get really nice error messages, I have to say, from Django in the browser. And here we can see I get the JSON back. And just to recap what we saw before, if I go into my Django project at the top level here, I have the URLs PY for the whole project. And here's some example code from last week when we were sort of learning about paths and views. And here, just like sort of what we saw Megan share in her demo, I'm saying, hey, Django, when you get an HTTP request where the URL starts with API/v1/Pokemon, I want you to go to this other URL's PY file that's in the Pokemon app, Django app. Right, and if I go over there, we have these routes again. This is the sort of converter that we wrote, which I won't go into now, but lets us deal with an integer ID or a string name being passed on the same route, which is kind of, we saw there's two approaches, the one that Megan did where you build out two different routes, or this one where you build your own converter and then you have to register it with Django. And to kind of dig into this a bit, if I look at the views for my Pokemon file, we're using the Django API view here, and that's what gets called here, a Pokemon, and we use this method as view that will return probably a function that Django can then use to return JSON data and stuff. And as I was talking about with Josh, there is more complexity with Django models and API views, but it lets us hook up all these pieces together. And you can see that here that we're using Django API view, we're using the Pokemon model, and we're using the Pokemon serializer. And just to very briefly recap with those. We have all these different models that we built. This one is for Pokemon, and we wrote a serializer for it as well. And I think I'll very quickly show that. That also uses our Pokemon model, and it interacts with indirectly with the moves model as well to get all the Pokemon moves. And we have this sort of custom serializer function. So this is our whole backend. And now our task is to see how to, we've seen how to write React, and really we're just gluing these pieces together now. So to kind of walk through what the project structure looks like for adding React to this application, let's go into the front end, and I'm just going to make my terminal a bit bigger because I'm going to be doing installing and such. And we'll close the backend out entirely. And let's go ahead and start building some things. So since we're going from scratch here, I'm going to need to create a new React project using Vite, our build tool. I do want this dot here because I do want this to be in my front end directory and just sort of all installed in there. And we want to use React. And I just want to use JavaScript. TypeScript is great, but we're not doing that right now. And so now that has the Vite build tool has built out for us our skeleton React project, right? Oh, was there a question?
Honestly, I think a lot of your stuff I turned off updating, to be honest with you, because I was worried about performance being bogged down.
Oh, we totally have a hot mic, don't we?
Some of your apps probably gonna be outdated.
I didn't choose this.
Yeah, you might have to update it real quick.
Okay. Robert, just FYI, you have a hot mic. I muted you for the moment.
Sorry.
No worries. So again, I've got my Python virtual environment activated. React doesn't care. This only affects Python related stuff. We've got all our project dependencies for our React application here in this package JSON file, right? And so I do need to run npm install, because I want to install those dependencies and just make sure that this app is working. And this will install React and maybe like the testing library or whatever else Vite has set up for us. It's going to create that node modules directory. I am going to create a git ignore directory because I don't want to put oh, and Vite in fact has already done that for us, which is great. So that node modules doesn't end up in our version control. And you can put git ignore directories in as many directories as you want in your project. And so here, localhost is really the same thing as that IP address 127.0.0.1. Localhost is in fact, I believe, a domain name that points exactly to that IP, which is our own machine. And our React app here is running on a different port. I'm just going to run this to make sure that it's working. So I now have, my two applications up and running. I've got my React app, which doesn't do much yet. And I've got my Django web server. Well, I turned it off, otherwise it would be running. Now we need to build out the React app and have them talk to each other a bit. So we pretty much want to get rid of all of the sort of default code that Vite built up for us. It's just going to get in our way with what we want to do. So inside the source directory, I am going to go ahead. I'm just going to delete app.css. Let's see what's in index CSS. I think I'll just delete index.css as well, in fact, because we might want our own later. Let's look at the two JavaScript files, and we're probably just want to delete all this stuff as well that we don't need. So this, I don't have any CSS that I'm using, right? So I'm just gonna get rid of it. The rest of this stuff is fine, and this is what we want for like a very minimal React app. Over here, there's a bunch of junk that I don't want, that we're not using. We're not using the React logo. We're not using the Vite logo. We're not using this. We're not using the counter. And in fact, I don't want any of that stuff at all. So I'm just gonna do something really simple. Just a hello world. And if you want to, you can get rid of, there's like the React logo here as well that you can like delete and stuff in source and assets. So we're just gonna do some cleanup. And I do want to use Bootstrap for this project. So I am gonna install the React Bootstrap library. And for that, I do want to be in the same directory as package.json when I'm running my npm commands. And again, it doesn't matter that the Python virtual environment is running, it doesn't interact with anything outside of Python. So we're going to go ahead and install and save React Bootstrap. I'm going to go ahead and do some very simple setup of our main React app. Let's just import a container. And I'm going to import directly from, this is actually the file that contains the container function. So we can just do a default import. I'm going to import a row as well. And I'm going to do something really simple. And I'm going to add a little bit of sort of alignment rules here. And let's get rid of that H1. And let's just put in here. In fact, let's put it right here. Let's make our Pokédex, and that'll be one row. And I'm going to make another row and just put a div in there, or maybe a paragraph, and just say, this is our Pokédex stack. And let's run this dev server and make sure that everything's working. And I am going to open up the console, which I always want to have open so I can see what's going on. So this is the basic project structure, right? Of these backend and front end directories. Now, really, we're getting into design, because I'm building my front end app to be a Pokemon viewing app that's going to use our API. So, you know, I don't directly have to have like each route in my Django backend match, say, like a page, but there is a correspondence, and this is where it starts to be useful to think about features, right? Because a feature is a user can see all the Pokemon. To implement that feature, I have to build a Pokemon page on the front end, and I have to do all the backend work in Django with models and serializers and an API view and a route with urls.py so that our React app can get that data. So now we're starting to think about building features that have like front end and back end components. And I think the next step here I want to do is add a little bit of routing so we can build up some pages and then start implementing these features. So let me actually go ahead and install React Router as well. And I probably need to do install React router dash dash save. And then in our source directory for our fronting code, let's make our routing file. And this should look familiar from the other week, though it's been a minute since we've looked at it. But we're gonna create a browser router. And I probably need to install React Router DOM as well, don't I? Because that's, am I correct that that's a separate package? Pretty sure it is. And in fact, if I dig inside known modules, I can see what's hiding in here. And if I go way down in node modules to where React Router is, I see React Router is in no modules, but no React Router DOM. So let me go ahead and install it as well. And now I think this should be happier. And we can create a browser router just like we have seen. And we're gonna have to build some stuff out here. We're gonna have to build out some pages. Let's start with the home page. And then there's going to be a bunch of stuff that links to this homepage. And so I also need to import our homepage component, which is just app. And I do want to do a default export for my router so I can use it later. And let's start by just building out our Pokemon page. Let me go ahead and create a pages directory. And inside there, let's create our Pokemon component. And this is going to be a pretty simple Pokemon component. I'm not even going to add a lot of styling to the row right now. And that's really all it's going to be. I'm going to go ahead and add a Pokemon page as a child off of our homepage in the router. I probably need to add a homepage as well. Because I do want to have sort of an index here. And in fact, since all of these are pretty simple right now, I'm just going to go ahead and copy all of my code from the Pokemon page and reuse it for the homepage. And I'm just going to call it homepage. And since this is what we want to show up by default, I do want to set this as the index for my routing. And it is going to be the homepage element that renders here. So fingers crossed, I didn't have any issues. We just have to hook up our router. And I need to do a little bit of and we would probably also help to import this as well. And let's go ahead and use this router provider now. Actually, I don't need the app here at all. And let's run this and see what typos I made along the way. Or if this works. And this does seem to work, which is great, though I haven't like hooked up any of the routing or anything like that. But you can kind of see where we're starting to go here, right? I think for the moment, I want to, yeah, I'll build this out a navbar so we can add that as well, because we'll want to reuse that. And then once we have this done, then we can start connecting to our backend. So, we're building this feature. Like I want to view all my Pokemon, but just to get this going, there's already like a couple steps that we need to build up this front end skeleton, but then each future feature will be easier and easier. And let me make sure I am in the right directory here. So we're going to make a components directory like we've seen in the past as well. And inside there, let's put our navbar component and let's go ahead and build that as well. I'm going to keep this again super simple for now, just to get this up and running. And let's add a couple links. Let's add a link to the homepage. And something, it does not like something I did here.
Go back to your function, Adam. You're using parentheses instead of the
Oh,
bracket.
instead of the curly brackets. Yeah, thank you. Let's in fact just for the moment. Thank you, Dakota. And probably, if I'm doing it this way, I probably want to wrap everything in a fragment, though actually that shouldn't make a difference. Let's see what we don't like here.
It seems like you need a return statement and then those parentheses need to be curly brackets.
Oh, okay, thank you. I thought I could do this, as a, I forget the format for the arrow function where it doesn't have a return statement, but I must be getting lost in the syntax here. Thank you, guys. And let's run the format.
You might have an extra double quote.
That is totally it. Then that, in fact, was probably the other two. Thank you so much. And now that I finally built this thing, let's add it into our homepage and maybe our app.jsx as well. Let's see if this is working. If I go to my server here, we're getting a lot of complaints, but let's restart it. And I'm still getting some unhappiness. Probably because I don't have the full path right here. And let's try if I need.
It's your path. It looks like it needs to go back a directory, then into components.
Oh, yes, thank you so much. We are totally doing relative paths here. So I need to move up from, I'm inside pages. I need to move out of pages back to source and then go into components.
Yeah, you just need the slash. Yeah.
And I need to add an export here.
I think you just need to wrap it in curly brackets in the other page.
Let's see, I've got the home page where I've got the nav bar. But I think I'm not rendering the home page at the moment. So let's go ahead and add the nav bar to app.jsx. And let's just put it in another row. And let's see. And that would be because now my path has changed because app is not in pages. Failed to import.
I think it's /components.
Thank you. Yeah, I'm totally getting lost on the switch from Python to React. So now we have some routing set up. Though I need to add my outlet as well, right? I think that's the other piece that I'm missing here. Now that I've done this stuff, I just want to throw in an outlet. So let me actually. Let's get rid of these and let's just add the outlet right there. And let's go ahead and import that. Let's see if we're getting any better. So there we go. And I can actually, I probably don't want the nav bar on the home page at all. So now is probably a good time for a break. But we've built up the skeleton of our front end app. And the next step after the break will be to use Axios to make some HTTP GET requests to our own Django API. And I think what we'll do is I'll aim to have us wrap early so you all can get some work time in on this before lunch, because the next part is important for the first assignment as well. We already got a bit of a preview of this from Megan, but just to kind of reiterate, our next step here is we're going to add in an Axios call to our Django API to get Pokemon data. So the same way that in Django, if I open up another tab and I go to, let me spin up the Django server again. So we've got our backend all set up, and now we've built out a really simple skeleton on the front end. And now I want to use this endpoint that I've written right, API/v1/Pokemon to get my Pokemon data, and we're going to get it and populate it in here. So just the same way that you all did this a couple weeks ago with the Rick and Morty API, we're going to do this now with our Django API. And there's a little bit of configuration we have to do on the Django end. But we're almost home. And just to recap, the big picture here really is, once we are building this full stack app, you really want a backend directory for your Django application and a front end directory for all of the React stuff. Because although these work together, it's really two independent applications that for organizational purposes, we want to put in the same repo. So let me pause and see if folks have any questions here, because I know I went on for a bit, and then we'll take a 10-minute break. So what's on people's minds? Okay, take 10, get away from the screen, and then after the break, we're gonna take the final step and connect the dots and use our own API with our own React front end. So thank you all very much, and see you all in 10 minutes. So just to kind of reiterate what we're building here, when I go to the Pokemon page in my React app, and I'll put, in fact, let's just put Vite dev server somewhere off to the side here. Because it is important, because it does serve up index.html. Right, and in fact, I believe it's what, get localhost, I don't know, 5471 or something like that. Whatever port Vite dev server is running on. So all of this stuff over here is step one, just to get the React app running in our browser, right? We talk to Vite dev server, the browser sends a GET request. Beat dev server sends back the index.html, which includes the source link. So then the browser then makes another request to get all the JavaScript. And in fact, I can watch all this happening in the network tab. If I go ahead and clear it, and if I do a hard refresh, if I go all the way up here, lo and behold, my browser talks to Beat dev server. Well, this one's on Pokemon, so let's do that one more time. But my browser talks to Beat dev server. Beat dev server sends back index.html, which most importantly has this source link to all our JavaScript. And then this is a bunch of requests back and forth of the browser requesting all the things from the index.html to get all this React stuff. And now what I want to have happen is when I click on Pokemon, I want the React app running in my browser to use Axios to make a GET request to our Django server. Right, I want something like this. .0.0.1 8000 API v1 Pokemon. And I apologize that this diagram is a little messy, but I want my React app every time we go to this Pokemon page to make this GET request to our Django server to get this Pokemon information. And then Django server does all of the things that we've been learning over the past week with models and serializers and the Django REST Framework API view that gets hooked up so that whenever the Django server receives a GET request at this endpoint, at this URL API/v1/Pokemon, it uses models and all this stuff to get that information from Postgres, turn it into JSON, and send it back. So that's what we're going to build now. So what I want to have happen, and let me pause actually and check in if folks have any questions. This is a good time to sort of ask, I think, like high-level questions about what's going on. And if needed, I might just say like, hey, that's a great question, but let's come back to it later.
I guess I have sort of a high level question.
Yeah.
I guess once we are not personally hosting this, are we doing like local sort of addresses that don't involve our local machine? Like, would it just start with /API/v1? Or like, I don't know, how would that change when we actually have a place to store this information?
Yeah, that's a great question. So we will learn how to deploy our Django web server onto Amazon Web Services to run on a virtual Linux box in the cloud, and to deploy Postgres on that same Amazon Web Services on another virtual Linux box in the cloud, on how to have them talk to each other. But then the most interesting part, I think, is the point you raise of, hey, then how do I talk this application? AWS, it gives you like a URL with the domain name for free, but we could do, I'm just making this IP address up without going too much into sort of networking stuff, which I'm a little rusty on anyway. Essentially, every single server available publicly on the internet is the IP address is the unique address, right? And then what happens is you can register, it's called a host name with an IP address. So when I go to pets.com, that host name pets.com is registered with some IP address. And similarly, we'll get like, I don't know, my AWS server.com or whatever it is. And this first part of the URL, which is called the domain or the host, is the only thing that needs to change. right? Because that points to wherever our Django server is living. And then once Django gets the request, it cares about all this other stuff, and all this other stuff can stay the same. Yeah, that's a great question. And does that help a bit, Clarice?
Yeah.
Awesome. And the question of how do I tell my React app what the host name is? And we don't need to pass the port with public stuff. It usually uses like a default port, like port 80. We'll see that later, but for now we're hard coding this, but we'll see later how we can use environment variables to have React use different host names for development purposes and like production. Yeah, it's a great question. What other questions do folks have, or things that people are curious about? Okay, cool. Let's dive into building this. No, I don't want function documentation. I want pseudocode. So what do I want to do? I want to make Axios calls to Django API to get Pokemon data using that API v1 endpoint. I want this to, every time the Pokemon page renders, we should get Pokemon data from the server, right? From our API. And two, once we get the data from our Django API, we should render it so the user can see all Pokemon. So there's really actually, in fact, 3 different steps here. If I want to break this down, first, I just want to get my Axios request working. Then I want to make it so every time I load this, I navigate to this Pokemon page. We make the request, and then I want to render the data. So I'm kind of breaking this implementation down, excuse me, into 3 steps here. So I will probably need to install Axios. So I'm going to go ahead and do that. And let me go ahead and run the dev server again. And I'm just going to set up a little bit of skeleton code here. Can someone remind me in React when I want to make an HTTP request with Axios? What hook do I have to use so React knows what's going on?
Be use state and use effect.
Yeah, awesome. Thank you, Andrew. And what exactly is use effect doing for us with React?
It tells us when to call whatever function or something.
Yes, exactly. We can use effect to tell React when to execute a certain function. And I'm going to go ahead and in fact just write a simple placeholder method or function rather for the moment. And what else is use effect doing for us with React? And that's one of the key things that it's doing, Clarice, for sure. And in fact, I think I'll just put it. I think I'll just use our use effect right here just to sort of demo that. And we'll do get all the Pokemon. And there is one really important thing I'm missing from this use effect right now. That sort of is what we want to add by default with use effect when we get started. What would that be?
Dependencies.
Yeah, and can you expand on that a little?
Yeah, I guess so. Use effect is creating a side effect that's dependent on whatever we place in the dependencies bracket.
Yeah, exactly. So use effect takes two arguments, right? This is in fact one argument right here. Like if I wanted to, I could do, get Poke. We usually don't want to, it's a little easier to put this function right, to define it right inside the use effect. But we're actually passing two arguments. The first one is the function that we're going to call when the use effect hook gets fired. And the second is this array of dependencies that tells the use effect hook when should it fire, like what should it pay attention to, and kind of like it says right here in the docs, if present, effect will only activate if the values in the list change. So right now here, there's nothing in the list. Will my use effect fire at all if I don't have anything inside that array, this dependencies array?
Yes, on mount.
Yeah, exactly. And can you expand on that a little? Like, what is mount, and at what point in that process does the use effect fire?
I guess when the page renders, that's when it fires. That's like as deep as I know.
Got it. No, that's good, and I think this is where React starts to get a little more complex. So, like, mounting a component is when a component renders for the very first time, right? Like it didn't exist before, and it has to be created for the first time and rendered for the first time, and we call that mounting a component. And use effect fires after the very first render. And I'm sure all of you ran into this where you like write the use effect hook, but you're like, and you try to have it stuff happen, and you're like, wait a minute, I see the use effect was working to get the Rick and Morty data or whatever, but it wasn't updating stuff, and I have to use some React state. And the reason for that is the very first time use effect runs, it runs after a component renders. So like after our very first render. And if I go to my Pokédex here, in fact, we can look at using, there's a whole bunch of junk in here because we've got React Router. But if I dig all the way down in React DevTools, somewhere in here, inside this outlet, here we go. If we go all the way down here, I can see my Pokemon component. So the interesting thing is when I click to go to my homepage, that Pokemon component is gone, right? Which is what we want. And that's what React Router does for us, right? And then when I click back, it's there again. So this Pokemon component, it gets mounted and rendered, unmounted when I go to the homepage, and the homepage is mounted and rendered. And then the Pokemon page is mounted again when I navigate back. So because we're using React Router to move around, every time we're doing that, this Pokemon component gets mounted again. And so that means that use effect, every time this gets mounted, every time we navigate here with React Router, after the first render, use effect will fire. And can someone maybe remind me, like, what's the undesired behavior we see if we don't have that array at all with this use effect? What happens? Well, did anyone ever use effect, forget this, and then just see like their HTTP requests like on infinite loop firing over and over and over and over and over? Does that ring any bells? Yeah, that's what happens if we don't tell use effect what to look at, what to watch, what to activate if the values in the list change. Use effect just fires off like mad. Presumably there's some reason why Facebook designed it that way. I actually don't know. But so we need to at least pass an empty array so use effect isn't firing off infinite times. And so what we're saying here is, hey, use effect hook after this component mounts for the first time, call this function, but then don't do anything else. And just for simplicity's sake, I did a lot of typing here. I do want to put this back inside. And I think I'll just do it. I will in fact just rewrite my use effect. But I just wanted to kind of go through that a bit to kind of review what is going on with use effect here. And I'm not going to forget, it's incredibly easy to forget that rule, right? And so that's what the use effect hook does. Like Clarice was saying, we use it to tell React when we want to execute this side effect, this thing that's not a prop, right? We're not getting data through props. We're not modifying state. We're about to make an Axios request. And React uses the use effect hook to control how this happens in relation to stuff like updating state and rendering components. And we're letting React know that it happens so it knows what to do. So now we can start to get to the fun part, which is actually making the Axios request, right? So now I can do something like Axios.get HTTP. I'm just going to hard code it right now. Port 8000 / API / v1 / Pokemon. Django does get a little funny about leading or trailing slashes. I always forget that a little bit. And remember, with JavaScript, we can do this chaining of multiple methods. And I'm going to tell Axios to call its get function. And I'm also going to tell Axios, hey, if there is an error, this is what I want you to do. And you should always include some sort of catch. And error handling and requests. And what I want Axios to do is simply say, let's just say console log get all Pokemon error, and I'll pass the error as that. And for dev purposes, I'll add a pop-up so that I don't miss it by mistake. And so now I'm ready to go right. I've got my get all Pokemon. I've got my Axios. Let's see what this squiggly is about. It would help if I imported Axios. I'm going to get rid of that because that is going to throw me off the fact I didn't realize my browser was going to navigate over there. Hopefully I'm importing Axios from the right spot, which I'll tackle in a minute if needed. So now I'm almost good to go, right? But there's one piece that I'm missing from this get all Pokemon function. And I know we've just been doing tons of Django and Python, but what's the piece that I'm missing here from this asynchronous request that I'm making for my JavaScript code with Axios?
Well, it's gotta be get all Pokemon equals async, and then you also need like a let response equals await Axios.
Yeah, exactly. It would help if right, Axios.get is going to return something. It would help if I actually was capturing that return value. And then, Aaron, can you talk maybe a bit about like what are async and await doing here, or why do we need them?
I'll give it a shot. Async is just saying that the things are going to happen asynchronously, and the await is going to say, look, this response might take some time, so just wait to get the data back and don't move forward until it does. Is that
Yeah.
about right?
Exactly. And what would JavaScript do if we didn't have async and await there?
You just return empty data that would give us errors all day long.
Yeah, exactly. And why would it be doing that if we don't have async and await?
Because it just executes in order.
Yeah,
Doesn't do any hoisting or anything. It just line by line goes on, does its thing.
yeah, close, very close. You hit the key point, which is that like in JavaScript, like the execution will continue. Python works a little differently. I think execution, like if you make a asynchronous request, I think your Python program will actually wait to get the response back. The term here is like a blocking operation. Like certain things in programming languages are gonna block or not. Without getting too into the weeds, the way JavaScript is designed, a lot of stuff in the language kind of happens asynchronously. To go back way back to like when we looked at the call stack a little bit in the data structures week. Without this async await here, what JavaScript does is it says, cool, all right, I'm supposed to make an HTTP request here with Axios. Awesome. I'm going to fire off that HTTP request and then just continue on executing my code. Because JavaScript sort of makes this call, throws it on the call stack, and then just keeps moving forward, and it doesn't wait. I'm simplifying dramatically. It's kind of interesting. The term is like the JavaScript event loop. But in essence, we need to tell JavaScript to wait because asynchronous stuff is not blocking in JavaScript. And we can do that either with promises or async await. And you hit the nail on the head, Aaron, that the most important thing here is we're telling JavaScript, hey, this is an asynchronous function. I don't know how long it will take. I want you like to wait until it's done. I don't know if it's waiting or tracking, but JavaScript makes sure that, hey, it knows that it has to wait for this Axios call to return stuff before it can like put whatever's returning this response value. And I realized I went off a bit there, so I just want to check in and see if folks kind of have any questions about that. And then in a moment, we can run our code and see how it goes. Okay, cool. Well, we're awfully close. I've got my Axios, my async call set up in my Pokemon code. Let's see if this works. I'm going to go to the console. Even better, I'll go to the network tab. And I'll refresh this just to get a fresh start. Actually go to the home page. So what I would expect to see now, and this is good when like building and testing, is I do like to get rid of stuff and like look at error messages and think through what's supposed to happen. When I click on Pokemon, I should see a request here, right, to the Django server, and then Django should send back a bunch of JSON. So I got my request, and that's actually working great. It seems to have gone to the right spot. I got this interesting error, failed to load response data, no data found for resource with given identifier. And then if I scroll down here, there was, let's see, there was another error that I saw somewhere about cores. And I suspect there's a couple things going on here, but let's dig into it and see what's going on. First off, let me pop over to my Python console. And in fact, let me test and just make sure that I have this URL right. Let's use Thunder Client. And let's put this in. And let's get rid of that double quote. And let's make sure that this works. So this is good, right? I know that my URL is good. I know that that's correct. I know that my client is talking to my server. That's good as well. And what we actually ran into here, I believe, is more of a cores issue, which is what we're about to talk about, which is something called cross-origin resource sharing. And somewhere in here, I don't quite know where it's hiding, was a bit of a better error message, but it's kind of, let's see where it was hiding. So I think that was the, oh, there it is. It's hiding right in plain sight. The status of the HTTP response says cores error. And if I look here, somewhere in here, it's hiding somewhere in there in the network tab, but it's actually a bit easier to see. Right here. So this is a good moment to talk a little bit about what cross-origin resource sharing is, and then we'll see how to set it up. So this is sort of expected. So hopping back to my diagram here. Remember that the React app is running inside my browser, right? And then this JavaScript code with React is running in there. And then the JavaScript code is making a request. And we actually do have two different servers here, right? If I go to my React app, it's a different server. It's hosted on localhost. The Django app is on, well, also localhost really, but a different port. But it's two different servers. And if I go looking at digging a bit more into what we get with these HTTP requests. Let's see, where is the bit that I want to share here? There's a bunch of information HTTP requests that we don't really go into too much. And it's all in these request headers. Can everyone read this okay, by the way? Is this font size good? And actually the web security workshop goes into more depth on this. This is literally like you could use a program like curl on the command line or Python. Like this is what an HTTP request is. It's pretty much sent as plain text over the wire, over the internet. And we can see the type, the verb to get request, the URL, and the protocol. This accept header, there's all these headers saying like, hey, I want stuff back as text or as an image. There's encoding information. There's information about languages. There's information about caching. And then right here, there's this header host. And what this says is, this is the server, the domain name or the host name that this page was loaded from in the browser. And And that this is where this is coming from. Right, and I can see refer HTTP Pokemon. So when the browser sends a request to a server, it also says, hey, this is the server that gave me this web page to begin with, that gave me index.html. And the reason for that is, let's say instead of Pokemon, we were working with say like a bank. Let's just say Chase Bank, just for fun. And let's I'll just leave those right here for now. Right. And the browser's requesting stuff, and the bank is sending stuff back. I should have used green for those. So I'll just use maybe like a purple. Let's say all of the sudden the browser makes a request to some other server. Let's say we're on the Chase Bank site. Right, we've logged in to Chase Bank. We've talked to the Chase Bank server. Right, we've given it our username, our password. We're logged in. They've got a React app or whatever that's running. And all of a sudden we get like the browser sends a request. I don't know, get, you know, user account balance, or even worse, a request to take money or put money somewhere. And the browser sends it to some other server from the JavaScript running in React, exactly like what we just did here, right? One server, the dev server, hosted the HTML page that had the JavaScript for the React app and all that stuff. But then our JavaScript code wants to talk to another server. So, especially in the earlier days of the internet, but still today, it's really relevant. Like, people saw this as a huge red flag in terms of security, because there's all sorts of ways to inject malicious JavaScript or malicious code or pretend to be someone else. So the origin is this term for the server that like your index HTML came from, the server that you originally got the web page from, right? The origin. And if you try to make, if your browser tries to make an HTTP request, particularly like the JavaScript code running in the browser, from something that's not the origin, cross origin, somewhere else, that's a major security concern, because maybe someone has injected malicious JavaScript into the React app for the Chase Bank or whatever. And there's sort of all sorts of scenarios, but essentially like browsers, like and servers like don't really let you do this by default for security reasons. So I just kind of want to pause and check in and see if this basic idea of like, in fact, let me label this like origin, you know, or not origin. If this basic idea makes sense to folks of, we've got the server that like our browser made the initial request to load the HTML page, and that's the origin, and then anything else is not. So honestly, the Mozilla developer docs on this are quite good. And I think the way that they put it here is actually quite good as well. So by using these HTTP headers, by default, a browser like won't make requests from outside the server that originally sent the web page. But the server can tell the browser with these headers, hey, here is some other domain or whatever, some other origin that you are allowed to get data from. And it's not worth going into too much detail at the moment on this other stuff, though it's very interesting. And so to reiterate, again, for security reasons, browsers restrict cross-origin HTTP requests initiated from scripts. And by a script here, that means JavaScript code running in the browser. Right? And so here is sort of another illustration of the same thing. So we have to explicitly in our Django code say, hey, it's okay to make these cross-origin requests. And it gets a bit more complicated with like setting it up for a production environment. But in terms of implementing it for now and for development, it's actually pretty straightforward. So let me go ahead and demo that now. But before I do, again, I just want to check in to see if folks have questions. And if someone could maybe just repost that Mozilla developer docs link that I just threw in the chat into Slack, I would appreciate it. So the good news here is that we can install a Django package, a Django module to help us with this. And it is called Django Cores Headers. And in fact, I think already got installed at some point, which is even better. And let's see, actually, I don't think I've added it to installed apps in settings PY, but that is the next step here. Is we need to add Cores headers to installed apps and settings PY. And these steps are explicitly laid out in the lesson doc for today, so that'll be a good reference. We also need to put it in an area of settings PY that we haven't seen yet, which is called middleware. Without going into it too much, basically, if you think about like when Django gets an HTTP request, it does a bunch of stuff to it before it gets to our view functions. You can think of the HTTP request as like data moving through a series of tubes, through a series of functions, through a bunch of middleware, right? The stuff in the middle. And Django pretty much does this all the time with every request. And so by putting this here, it makes it easier because we don't have to constantly configure this for like each app and each endpoint and so on. So we do need to add a bit of stuff here. And again, this is in the lesson doc. And that one is already added, so I think we are good to go. So let's see if this works for us. There is one more bit we actually have to do. Which is, so there's this allowed hosts header, and what we want to add to use this cores package that we've just installed is cores allowed origins. And we have two options here. The easiest one to get started with is we can do cores allow all origins equals true. The other option would be to specify the specific ones, like say our Vite dev server. And this is telling Django, oh, excuse me. Hey, if you get like a request from this host, from this origin, that's okay. That's allowed, even though it's not originating from our own like Django web server. So for the moment, I'm going to comment this out and just do cores allow all origins equals true and see if we can't get this working. So let's go ahead and run the server. I don't have any errors, which is always a good start. I'm going to go ahead and do a quick sanity check to make sure that I didn't break anything on the Django side. And now let's clear all this stuff. Let me actually do a hard refresh. Though it shouldn't matter because I didn't change any of the React code. And now our Pokemon request returns. We haven't done anything to render the data yet, but now we are getting it. Right, so we are starting to learn a little bit about sort of networking and web security stuff. Again, just to recap, we have to tell Django that it is okay for requests coming from other hosts, other origins, other domains to be handled. To do this, we install a module called cores headers, and it's documented in the lesson material, but we have to update both installed apps and middleware and settings PY, and we have to tell Django what other hosts are allowed. And I would probably recommend just doing allow all origins, because you might end up using, say, a different port. And I think you might be able to do, I think you could just do localhost for all ports, but just to demonstrate, let's run this and see if this works with the more explicit port. So if I go home and Pokemon, everything's still working as expected. But if this was a different port like 5174, then we would see the same issue and it would be blocked. So I just want to pause and check here and see what questions people have about stuff.
Did you say that there was something we needed to update on middleware?
Correct. So in settings PY, and again, don't worry too much about writing this down because this is in the lesson doc for today. Middleware is a bunch of stuff that Django does every time it gets an HTTP request. The stuff in the middle from when the request comes in to when it makes it to our code and URLs PY and the view functions. And we need to add cores headers there because we want Django to do this on every request, and that's how cores headers is designed to be used. What other questions do people have?
Thank you.
Yeah, for sure. Absolutely.
Sorry. What did we put in, I guess, the installed apps? Oh,
we
okay, I see.
have to add it to installed apps as well. We actually have to do both, correct?
And Andrew put in a question in the chat.
Oh, good question. No, I see what you're saying. Let me jump there, actually. That is a great question. So as I am 99.99% sure the order that we put stuff here doesn't matter for installed apps, unless one depends on another, possibly. What I have been doing is, you'll note that all of these were the default Django ones that were already installed. These are Django apps and modules that we've installed. And then these are our own code. And I kind of follow the same pattern with import statements as well, where you kind of, it just makes it a little easier to see what's what when you're looking at, as you start to have more and more imports or installed apps and stuff. Basically, the rule of thumb is like start with the most fundamental stuff and then go to your stuff. So like the core Django stuff, the Django modules we install, and then like our own apps. But
Got it.
there shouldn't be any functional difference as far as I know.
Okay, yeah. Right, so it's not gonna make a difference if it runs or not if you don't have it in a specific position.
Correct. Yeah, great question. A little bit of an asterisk after that, but that should be correct. Middleware, I have to double check if the position matters or not. It might, but it's not relevant for us. But again, you know, like just as a rule of thumb, it's kind of good to, with these tools like Django, you know, not touch stuff unless we know what we're doing with it, because there's more and more moving parts. So just adding our things after the default stuff that they've already installed is just a good habit to get into generally.
Got it, thanks.
For sure. So let's take our JavaScript code home, because we're getting data, but we want to we want to render it, right? That's kind of where we've been going with this all morning. And so can someone remind me, like, I've got this data I'm getting this data back. The use effect hook is working, right? We saw that happen in action. I can see it right here, and I can see it in the network request as well. How do I use this data in my component?
Should we make a use state to
Yeah,
capture?
Exactly. The question is, like, how do we get the data out of the use effect hook, right? Because you all know from having done this, like, if I just do like return response and like, you know, pokey data equals get all that, and then I try to use pokey data here, that none of that's going to work with React. And the reason being, remember that this is an asynchronous function. We don't get to control quite exactly when this happens. So the rest of this stuff has to render. And also remember that, like, the way that React works, really there's two ways to get data into a component: props and some sort of side effect with use effect, which is normally an Axios request. And then the question is, once we get data in, how do we use it? And how does React know that it's there? And how does React know when to render stuff? And with props, it's a bit more straightforward. You get the props whenever props change, like whenever the value of a prop passed to a component change, React knows to re-render that component. And if I have some prop here, you know, like pokey, I know that I can use it here. The other way to deal with data and re-rendering stuff is with state, right? Because with a component state, if the component state changes, React will re-render that component. And state is also like one of these core React concepts, and all these pieces work together, right? So I can have this Pokemon component mount, fire off this use effect, stick the data that I get from it into component state. React will do the work of re-rendering the component, making sure that the data is there in the component state, and then we can use it. So let's create a little bit of state and save our data. And that's gonna look something like this. We need the use state hook. And we're gonna have it be set to an empty array. And we're gonna do something like this Pokemon variable that's just gonna contain our data. And I am gonna rename it to this, because even though they are different names with the uppercase and the lowercase Pokemon, I just know that's an easy mistake for me to make. So I just want to avoid even making that mistake to begin with. And we're going to use useState and pass it a default value where initially Pokemon state will be an empty array. So the very first time that this component renders, Pokemon state will be an empty array. So I'm just gonna put something in here just to get the ball rolling. Let's do an unordered list. And in here, let's do Pokemon state map. I'll just use P for Pokemon. And let's have it look something like this. Let's have it return a list item. And in it, we'll put, it's probably .name. I might need to do a little cleanup here. We'll look at the shape of our data in a minute, but just to get this ball rolling. And in fact, let's also I'll just name this Pokey and index. And so this is Pokey.name. And can anyone tell me why did I include the index here? What am I about to do with it? And I kind of am already doing it.
Using index as the key.
Yeah, and what is this key attribute doing on this list element to begin with? Why do we want it there? And if the answer is I'm not quite certain, that's a perfectly acceptable answer.
Yeah, I think Matthew Peterson said it in the chat, unique identifier.
Yeah, exactly. I need the key to be a unique identifier. Thank you for pointing out the chat. And the reason I need this to be a unique identifier is so React can uniquely identify and find this list element. Because React is doing all the work of updating stuff in the DOM, remember? So when we render lists of stuff this way, we need to provide a key so React can find these things. And it looks like I have some sort of syntax parsing issue going on. And it is let's see what there would be, because my map needs an opening and a closing parentheses. There we go. The syntax is always a little weird with this stuff. To be honest, once this gets more complex, I often just break this rendering logic out into a separate function. But let's see how we're doing now in terms of rendering Pokemon data. Let me go to our homepage. Let's go to Pokemon. Let's go to the console. We're almost there. The last piece I have is I need to put the data in state. Right? And in fact, like I could, if I had some default data there, but this is the last piece that I need right here, is if we look at our response, I can look at it here. I can look at it here. Though in fact, I really want to look at it in the console. because it looks like Axios adds an extra layer, right? Where in the network tab, we can see the raw response. Here we can see that Axios actually sticks it inside this property data on this object, along with all this other stuff. So let's go ahead and set Pokemon state, and I'll just log that right there that way to response data, right? And so now my component mounts, use effect fires, it calls this asynchronous function. JavaScript keeps doing its thing, but it knows when this Axios, when this HTTP request returns, cool, take the value of that and stick it in this response object. JavaScript knows that that's asynchronous. Now let's update our component state. And because we did that, React says, oh, my component state has been updated. Things have changed. I better re-render. So hopefully now we see some Pokemon. And indeed I do, though I see an error. So let's see if the error repeats itself. And it doesn't. So I'm assuming that error is just from when I was implementing. And now I've got my Pokemon data from my Django API. So this is probably a good stopping point. I know I went a bit long, but I figure we can at least wrap up early and give you all time to start digging into this. And so have sort of like a bit of a longer work period today. But I'm curious, what questions do people have, or what bits would you like me to go over? Cool. Let me go over the assignment. And we can talk about that, and then we can finish the lecture early. And if you all want to break and come back from lunch a bit early to work on stuff, today's sort of an independent work day. Though, if you all want to, I would encourage you all to work in teams, and get started on the assignment. Or if you want, you can finish up. I got through the Pokemon, but we also wanted to show Pokemon moves, and that could be a great way to dig into this stuff more as well. How are you feeling? How are we feeling about this, by the way? Like, pretty good, like a little more unsure, or like pretty good, but I just need to get my hands on it?
I think I just need hands-on.
Cool. Yeah, there's a lot of pieces now. The cores piece is the one bit that's a little magic, I know. And again, that's where honestly, I think just following along with the curriculum is going to make it easiest. So today, pretty much, let's see. Let me make sure I'm looking at the right thing here.
That's not the right assignment, Adam. It's linked in the curriculum.
Oh, I'm so sorry. Give me just one moment here, folks. Thanks, Francisco. I just had my brain in too deep in the Zoom. Yeah, this one looks much closer to what we should be doing. Sorry about that. Yeah, and this one is linked in the curriculum, folks. So we're going to continue to build on the school assignment. And by the way, while we don't want you all to go to this as a starting point, we do have a solution branch. So if anyone is still working on previous school assignments, maybe look at the last one and use that solution branch. So you can get rolling on this. Though again, I share this with a little bit of hesitation because I really don't want folks to take shortcuts, but since these do build on each other, I want to make sure you know that that's there so that you can focus on first on today's assignment. And we're going to be building a React app. And you're going to need to update your student Django serializer a little bit. You're going to need to create a React app and create a page for subjects that students are taking, to list all the subjects that, well, really all the subjects that are available. Specifically, we're going to want all the users taking a particular subject. And then we're going to want to see everyone. I got these a little mixed up, but everyone taking a particular subject and then all the subjects with all the people. We're going to want a list of all the students and then a student details page. So really each of these is its own feature. And I would tackle each one of these end to end, get it all the front end code and all the back end code working for the subjects page for API/V1 subjects before you move forward. And that's the right way to tackle this. You don't really want to do all your front end stuff first because there might be something you forgot. And also because, as you sort of saw with Megan's demo this morning, once you get one of these features working, you can borrow a lot of the code that you wrote as guide code because there's really similar patterns. So the first thing to do is get one thing working end to end. And you'll need to add a React Router browser. You'll want a navigation bar. And you will have to set up some cross-origin resource sharing with Django. So that's the task. What we also have here is there is demo code in addition to the code in demos and notes that I'll push up, but in the lesson for everything that we were going through. And there was a bit that I was not able to get into here with Pokemon moves. Like if we go to pages here, we can see here's the code for a Pokemon moves page. And similarly, we have backend code for that as well. So I think that can be a useful reference just in case anyone's not aware of that. So that's the plan. Let me go ahead and stop the recording here and then we can dive in.